so let's talk a little bit about the motor. It's a 24 volt motor, 250 RPM. I wouldn't go below 200. With 250 RPM, I get about 4 stitches a second on max speed. 24 volt, and what is quite important is the shaft comes out on the left as the shaft is facing you. You can get them coming out the other side, but make sure you get a left-hand one. Here's an example of a seller online, left type, right type. You want the left-hand type. These are made for like electronic scooters, or you know, if you want to make a little go-kart. You can get them at different voltages. Make sure it matches the motor. Stock, it comes with a lot of random stuff. Now you could just cut the wires off and insulate them with heat shrink. But what I did is I took it apart and I removed all the unneeded wires. You know, like I don't need indicator lights or, you know, brake lights. One thing that is important, the electronic lock, that actually means the ignition. So initially I cut that off and the controller wouldn't work. But you need to bridge those 2 wires. I've done it on the circuit board inside, but as long as they're bridged, then the controller will work. If they're not bridged, it literally won't work at all. Right, this is the adapter I bought, 240 volt AC to 24 volt DC adapter. I don't really know how many watts my motor is, so I just went for a 10 amp supply, probably a bit over the top, but it doesn't matter. And that's got a standard 5.5 millimeter DC connector, which you want to put on the input of your controller. That controller came with a Hall effect foot pedal, so you need to make a little wooden base for it. Cut out the bottom, because when you press it, it extends out the bottom. Right, so first thing you need to do is drill your holes in the machine. This machine's on its side right now, and as you can see, I've made the holes slightly too big, and that allows for a bit of play, you know, because you're hand drilling this and it's never going to be perfect. The mounting screws on this motor, 6mm metric, so I did 8mm holes. The shaft is a 10mm shaft, and I did a 12mm hole. Right, I don't know if you can see, but this surface actually slopes in. This is due to the way this base was cast and sand or some sort of mould. It needs an angle so it can release out the mould. So what you want to do is get a file and just, it doesn't need to be perfect, just roughly match the angle on the mounting studs. You probably can't quite see it on camera, but you can see I've taken a file to it and just roughly matched it so it sits kind of flush. Right, see, these are the screws I'm using to mount it. So you have to shim each screw, and it's a bit trial and error here. I've used just little 1mm pieces of plastic, apart from on one where I've used I think it's a 2 or 3mm piece. I'll put the measurements on the screen, and that's so when you mount the motor is dead on 90 degrees to that pulley there, and as you can see, this surface is not 90 degrees, that surface is. So you can use a straight edge on this surface to get this shaft aligned that way, and then you can use the top surface here to align it on the other axis. Well, that's the motor mounted up. You can see why I've slightly over drilled the holes, because the camera's probably not picking it up very well, but that shaft isn't perfectly central. But because I drilled clearance all around, it doesn't matter, as long as the shaft isn't rubbing on the cast iron of the mounting. You can see I put the shims in to align the shaft with that crank pulley. You can just use a square to make sure that's 90 degrees to this surface. It's not perfect, but it's near as damn. And then the same thing on the top side. So it's almost easier on the end of the shaft. If you use a square, make sure the end of the shaft is square. Again, not perfect, as long as it's pretty close. It's just trial and error with these shims to make sure the shaft is parallel with that shaft there. Right, so you've got the motor fitted now. You've got it shimmed up so it's nice and parallel with that shaft there. So now you need to fit the controller. So what I would do, I'd get the controller inserted nice and flat against the back surface. What you want to do there, and it's a bit fiddly, but get a little permanent marker and draw around it, because you're going to need to drill 2 holes to mount this. So the motor controller normally comes with this plate to seal the end here, but without the holes in. Much the same as this side here. And what I've done, and you don't have to do it, This was just a random piece of scrap aluminium I had, but I made a new top cover out of 4mm aluminium so I could then tap these holes. So when I mount it, and you can see my holes drilled here, I can use a normal machine bolt. Whereas if you use this cover that comes with it, you'll need to use like sheet metal screws that will screw into this. One thing to note, if you use sheet metal screws, there are components in here. And I drilled these holes in such a way that if I put too long a screw in, it wouldn't touch the components. With the sheet metal screw, you can't have it sitting flush. You have to have it fully threaded in, and there'll always be a bit of stick out on the other side. So just make sure when you drill the holes for that, make sure there's clearance for the components in there. Right, so you've already marked these lines for where the controller needs to go. And you want to take your cap off with your holes already drilled on the cap where you want them, and then mark those 2 holes there. This is a lot easier after removing the motor, obviously. And then drill those 2 holes, firstly from the bottom using a pilot drill, like a 4 or 5mm, and then go in from the top. I drilled 8mm holes, even though I'm using 4mm screws, 6mm screws. And that is so, in any slight deviation using a hand drill, it doesn't really matter. There's a bit of wiggle room. Right, so that's the motor and controller fitted. The wiring's dead easy. The red and black are your power in, but I've actually installed one here. Just need to solder them on there. The yellow and blue, they connect to the motor. Because it's a DC motor, it can spin either way. Red to yellow. And that way I get, is it anti-clockwise rotation, which is the rotation I need. But if it's incorrect, all you need to do is swap these 2 wires around, or swap these 2 wires around. It's not an issue. This is the input for your controller. What I've done is, rather than plug the controller directly into this, I've fitted a 3-pole magnetic switch in this pre-existing hole up here. You don't have to do that. I just thought it was nice. And I've got a small wire running down from there that connects to the controller output here. Just some points to note. I had to make some clearance for this screw head here. And I've used washer head screws, just because they're nice and wide and flat. I don't need to use washers then. Don't use countersink screws, because if you haven't got the holes completely perfect, the screws will try and centralize themselves and you might crack the aluminium mounting points of the motor. I've got my 24-volt power supply. That's wired into the 24-volt input on the controller. The controller's wired to the motor, or connected to the motor. And obviously the input for the Hall effect sensor pedal is wired up to the magnetic plug. So now it should rotate. I've actually just bought a single pulley because I've realised once it's lined up, you only really need 1 pulley for either of the machine pulleys. There's a slight deviation, but it doesn't really matter. You will have to make up 2 different belts for each different speed. You can buy these pulleys relatively inexpensively. If you just buy a single pulley, mine costs about £12 or £13. Obviously, you need to make sure the bore matches the shaft. So this motor has a 10mm shaft. This is a 10mm bore. And as you can see, it fits nicely. All you got to do is tighten up these grub screws here, and that will lock the pulley to the motor. Right, so you can buy this stuff just by the meter. It's a polyurethane belt. You get it in this kind of textured, grippy green stuff, or you get like a stretchier red stuff. I'd recommend the green stuff, and it's very easy. Just cut the 2 ends perfectly flat, and you melt them together with the lighter. It doesn't have to be perfect. You always get a bit of a seam, so use like a Stanley knife or something sharp just to clean up that seam a bit. So I'm just fitting the belt to the pulley. This belt could be a little bit shorter, so it's a little bit tighter, but as you can see, it slops on like that. I can control it very slowly or full speed. Now in the future, I might add a tensioner that keeps tension on the belt. From my testing, it doesn't really seem required, as long as you make the belt the right length. And you will need 2 different belts for each pulley. One point to note with this type of motor, so this motor is reduced in speed by something called a worm gear. It basically looks like a screw thread, and it's got a gear that engages on that screw thread. It works very well, and it means that the motor shaft can come out at a right angle to the motor. But with a worm gear, it can only be driven from the worm. That means it can only be driven from the motor in this case. So what you can't do with this, you can't rotate the shaft. If you rotate the shaft, you'll damage the worm gear. So that means no use of the hand wheel unless you disengage the belt or take the belt off. Well, that's just a general overview of what I've done. What would I change? Probably not a lot. I want to make a proper little housing for this cable because hot glue just looks a bit shabby. Again, I've ordered a single pulley because just one pulley can work on both of these pulleys. Even though it's slightly offset, it doesn't matter. Maybe add a tensioner in the future, and that way you could run a slack belt, and then if you did want to use a hand wheel, you could just release the tensioner so it will slip, and then you could use a hand wheel without damaging the motor. And obviously make a slightly nicer mounting point for this pedal because chipboard is horrific.